Hello, hello. Yes, so I'm going to talk about Locus. Yeah, so I'm going to talk about Locus in this video. So let's start with the definition of Locus. So, what is Locus? Locus is a bunch of points uh, that forms an equation, bunch of infinite points. So let's say I have it is associated with the coordinate system. Okay, let's say I have this circle right here. Uh, there are infinite points in this circle. Let's say this is a random point, this is a random point, this is a random point. There are infinite number of points in this circle. So the equation that represents this all infinite points is known as the locus uh, of that thing. So let's say what is the locus equation of this circle? So we know that circle equation is x squared plus y squared is equal to a squared, where is the radius of this circle. So this is the locus equation of this infinite number of points that represents a circle. So yeah, this is basically what locus means. Uh, the equation that represents the number of infinite points uh, that are associated with that equation. So let's say if I have this equation right here. Uh, this is a general equation like this. This plus this is equal to k. K is a constant. This is a general equation for this square. Okay, sorry for this triple diagram. This is a square. So if there are infinite point number of points in the square, then the equation representing those infinite points is this equation. This general equation that represents the infinite number of points in this area in this square that represents a square. These are known as locus. This is basically known as locus. This is a definition of locus. So yeah, basically the idea of locus is this only infinite number of points. So let's do some problems. Okay, yeah, let's take this problem first. This is a basic problem. Find the equation of locus of a point which is at a distance 5 from this point. So what information is given to us? Find the equation of locus of a point which is at 5 distance 5 from this point. So let's say let's visualize this diagram. This is the coordinate. This is the coordinate xy plane, and the point is 4 comma negative 3. So where does 4 comma negative 3 is? Let's say this is 4, and here we have negative 3. Okay. This is negative 3. So the line joining this point is the point 4 comma negative 3. Okay, let's say I take any, this is, let's say distance 5 units distance. So in the radius of this distance, I can, okay, we need to find the locus of this distance points. Okay, this points. Okay, then this can form this entire points. This is also distance of 5. This is all the distance of 5 from this point, and this is all distance of 5 from this point. Okay, this. So basically, this forms a circle. So we are going to get the previous form, but not. This is not. This does not have the center as you know center as origin. So this does not give the this form general form x square plus y squared is equal to a squared. But this is gonna give us the homogeneous form x square plus y square plus uh, 2gx plus 2fy plus c is equal to 0. This is the homogeneous form, or we can say x minus h whole square plus y minus k whole square is equal to a square. A is the radius of the circle. So basically, in this example, we have radius as 5, and the center of the circle is h and k. So basically, here h comma k is uh, h comma k. What is h comma k? H comma k is negative 4 comma negative 3. So we have 4 and negative 3 as the center of the circle. And if I substitute that in this, sorry, this is positive 4 plus y minus this is negative 3. So I can use the general form of the circle. If I get to know what the shape this is forming, then I can use this general form circle to find the equation of the locus points. So this is x minus 4 whole square plus y plus 3 whole square is equal to 5. We can say, sorry, 5 squared. The radius is 5, and this is radius squared basically. A is the radius, okay? So, sorry for the uh, small blunder. So, let's expand this. If we expand this, we get this form. We get the homogeneous form of the circle. Okay. So let's also write the homogeneous form. Okay. So if I expand this thing, this is a minus b whole square, x squared plus 16 whole square is 16 minus 2 times x times 4 plus y squared plus 3 squared is 9 plus 2 times y times 3, and this is here is 25. 5 squared is 25. So let's write x squared plus y squared minus 8x plus 6y, and we have 16 here. 16 plus 9 is 25, and this is also 25, so this gets cancelled. So x squared plus y squared minus 8x plus 6y is equal to 0. Here we can see that uh, if we gotta do analyze this more, so we can see that there is no constant c in this equation. For any equation in coordinate system, is if it does not contain any constant, that means it is passing through origin. So to draw this more accurately, what I can do is let's erase that. Okay, this and this. What I can do is this is the 4 comma minus 3 point. I can okay, I can draw this like this. Okay, shit. Okay, sorry. I can draw this like this. Okay, like that. You know the drill here. What I'm trying to say. Okay, so basically, this is a locus equation for this problem. This is first method. If you do not have any idea about circles, let's say you do not have any idea about circles, you basically know the basic terms of coordinate system like distance formula, and like that you can use that thing to find the equation below. So what is given? Let's say I'm assuming p of x comma y point. Okay, from this point right here, which is, let's say, 4 comma minus 3. Let's say this point is a. Name this point as a, and the distance is 5 units. So I can so what is we can write in equation like x minus 4 whole square plus y plus 3 whole square is equal to 5. Okay. By using distance formula, which is for 2 points, is x1 minus x2 whole square plus y1 minus y2 whole square, which is PA distance. So here PA distance is 5 and x1 is x, x2 is 4, so x minus 4, and y1 is y and y2 is negative 3, so negative into negative is plus. If we let's solve this equation. If I squared on both sides, let's square on both sides, I get x minus 4 whole square plus y plus 3 whole square is equal to 25. So as you can see that this thing right here and this thing right here, I wrote this thing right here, it's same. So this is another method by using simple terms. So I have to tell this method first and go to this method. Okay. So anything, we can do anything. Okay. So basically the solution for this problem is this. Let's move on to next problem. Okay, let's do this problem. Find the equation of the locus of a point P such that this condition satisfies where A point and B point are given, and another condition is given that uh, 0 is greater, okay, less than mod A is less than mod C, where the magnitude of A is greater than 0 and the magnitude of C is greater than A. So we have given find the equation. Oh shit. Sorry. Okay. Uh, Find the equation of locus of a point P such that this condition satisfies. Let's assume a point P like we have previously assumed to continue the problem, and we have given a point A and point B. Let's say this is A comma 0 and this point right here is negative A comma 0. And as we can see that these two are mirror images of each other. If this distance is A and this distance is also A, okay, okay. So such that this condition satisfies. So locus of point. So this given, as we know that if I take any point P of x comma y in the plane and satisfy this with this condition. Okay, so we have PA as root of x minus a whole squared plus y minus 0 whole squared, and PB distance, if I write, it is x minus 0 whole squared, and it is y, sorry. Okay. X1 is x, x2 is negative a, plus y2 is also 0 in this case. Okay, yeah. Okay. So what does this have given? So the given condition is pa squared plus pb squared is equal to 2c squared. Okay, and if I squared this thing, I get pa squared as x minus a squared plus y squared, and pb squared as x plus a whole square plus y squared. Okay, minus into minus is plus, as we know that. So let's write down that thing. Let me zoom in to write clearly. Ah, okay, x minus a whole squared plus y squared plus x plus a whole squared plus y squared. This is going to be equal to 2c squared. So let's expand this two terms right here. So this is going to be x squared plus a squared minus 2xa plus 2y squared plus this y becomes 2y squared, and I get x squared plus a squared plus 2 times x times a is equal to 2c squared. So here 2xa and 2xa gets cancelled, and I get x, this x and this x combines get 2x squared plus this a combined 2a squared plus 2y squared is equal to 2c squared. If I divide both sides by 2 in this equation, I can cancel all the 2's, and I get this equation as x squared plus y squared plus a squared minus c squared is equal to 0. If I see this clearly, this term and send this term right here, or sorry, subtract this constant term on both sides, I get c squared minus a squared. So right here, this represents a circle with center 0 comma 0, and this is the radius as r square. We can say r square is c square minus a square. If I write r only, then I get this thing right here, r as this thing. Okay, so this is the locus for this uh, problem, locus equation for this problem. Okay, so it should satisfy this condition also, because we have under root of, so this condition holds true here. This condition holds true because if c is not greater than a, then this term will be negative, and that does not possible in the uh, real xy plane. It can be possible in imaginary xy plane, and it is known as Argand plane. So yeah, for now, this condition also holds true for this equation right here, so we are okay with it. So our problem is correct. Let's do this. Find the locus of the third vertex of the right angle triangle. Shit. Okay, find the locus of the third vertex of the right angle triangle. The ends of whose hypotenuse are this. Okay, let's construct a right angle triangle. Uh, this is the base. This is hypotenuse. Let's call the vertex as A, B, and C. Find the locus of the third vertex of a right angle triangle. The ends of whose hypotenuse are this. So let's say this is the 4 comma 0, and this is the 0 comma 4. These are the two ends of the hypotenuse. This is hypotenuse. Hypotenuse is the longest side of the right angle triangle. So hypotenuse is given, and the third vertex B, let's assume that as x comma y. So we have to find the locus of this equation right here, of this point right here. Okay, this x comma y point, the third vertex of the right angle triangle. Okay, so What we can do here is we can use the Pythagorean identity, which states that AC squared is equal to AB squared plus BC squared. So this is the Pythagorean theorem, which states that the hypotenuse squared is equal to the sum of the squares of the uh, two other sides of the right angle triangle. So I have AC. Uh, let's calculate the AC. AC is the distance between these 2 points, which is hypotenuse. It is x1 minus x2, 4 minus 0, plus y1 minus 2 is 0 minus 4 whole square. Okay. So in some textbook, the formula is like x2 minus x1. It doesn't really matter because we are squaring in this thing. So you can do uh, anything. Okay, 16 plus 16. 4 squared is 16 and 4 squared is 16. This is 2 times 16, which is 4 root 2. I can write this. 16 is square root of 4. Okay, so I found AC value. AC is 4 root 2 and AC square is 16 times 2, which is uh, sorry, 32. So we got AC squared, and let's calculate AB squared and BC squared. So AB is distance between this and this. So let's calculate. This is x minus 4 whole squared plus y minus 0 whole squared. And if I squared AB, I get x minus 4 whole squared plus y squared. Okay. And I have C point as 0 comma 4, 4, 4. Sorry. So if I calculate BC, I get root of x minus 0 whole squared plus y minus 4 whole squared. So let's square on both sides. I get x squared plus y minus 4 whole squared. Yeah. Yeah, basically that's it. Let's plug these things into this condition. I got AC squared is equal to AB squared plus BC squared. AC squared is 32. AB squared is x minus 4 whole squared plus y square, and this thing right here is uh, x minus 0 whole squared plus y minus 4 whole squared. BC is AB is this, BC is this, and 32 is equal to x squared plus 16 minus 2 times 4 times x. 2 times 4 is 8. 8 times x plus y squared plus x squared plus this thing right here, y squared plus 16 minus 2 times 4 times y is 8y. Well. What we have? 2x squared. I have 2x squared plus 2y squared. This y squared. And I have negative 8y, negative 8 minus 8x plus 16 plus 16 is equal to 32. This 16, this 16, this 32 will get cancelled because the 16 plus 16 is 32. And if I subtract both sides by 32, these both gets cancelled, and I I am left with 2x squared plus 2y squared minus 8x minus 8y is equal to 0. And if I divide by 2 on both sides, I get x squared plus y squared minus 4x minus 4y is equal to 0. So basically, this is a circle which is passing through the origin because we do not have constant here. And yeah, that's it. The locus of this right angle triangle, sorry, not right angle triangle, but the points representing the right angle triangle and the locus of the third vertex point from these two hypotenuse points is a circle. This represents a circle. Okay, let's move on to the next problem. Okay, two more problems are left here. A and B are two given points. Okay, let's take A and B 2 points. Find the equation of locus of P so that the area of the triangle PAB is 8.5. Okay, let's say I have the triangle here as this is P of x comma y, and this is A point, this is B point. Shit. Okay, this is A point, this is B point, this is P of x comma y point. I assume the point as P of x comma y so that I can calculate the equation, the locus. So this 3 points area, this triangle area forming a triangle, this triangle area is 8.5. Okay, this area is 8.5, and yeah, basically that's it. I need to find the locus of this point P and set that the given conditions. Okay, so if I have given a 3 point, I, if I have given 3 points, and I need to calculate the area of the points, the formula is 1 1 1 x1 y1. Sorry, not x1 y1. This is x1 x2 x3 y1 y2 y3 is the area of triangle PAB right here. This is basically determinant of the matrices form of this triangle. Sorry, of the area of the triangle. We can this method will be easier than remembering the old textbook formula, which is like this. It is like x1 into y2 minus y3 plus x2 into like that. So instead of doing that, I can simply use the determinant form for this thing. What the hell is this? Okay, so oh, fuck. Okay, so okay. Oh, shit. So if you don't know how to calculate a determinant of a matrix, don't worry. Let me write down the formula. X1 into shit. Okay. X1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. This is formula. So this is the old textbook formula, or we can use this formula. Both are same. So let's substitute this formula right here. I have x comma y, and let's say a point. Sorry. X1 x2 as x comma y, x2 x3 as uh, 2 comma 3, 2 comma 3, and x3 x3 y3 as minus 3 comma 4. Is it minus 3 comma? Okay, minus 3 comma 4. Let's substitute this right here. Okay. Hmm, this thing right here is 8.5 given. If I multiply both sides by 2, I get this term right here, and this term as 2 into 8.5. 2 into 8.5 is 17. So we know that the right thing here is 17. So x1, which is x, and the second term is y2 minus y3. Y2 is 3 and y3 is 4. So 3 minus 4 plus x2 is 2, and y3 minus y1. Y3 is 4, y1 is y. 4 minus y1. X3 is negative 3 plus negative 3, which is x3, and y1 is y, and y2 is 3. Y minus 3 is equal to 17. X into minus 1 plus 2 into, sorry, 2 into 4. 2 into 4 minus 2 into y. I multiplied this thing, minus 3 into y plus 9. 3 into 3 is 9, is equal to 70, minus x minus 2y plus 8. Hell is this? Hush. Minus x plus 8 minus 2y, and this is minus 3y plus 9 is equal to 17. Okay. 8 plus 9 is 17. So this gets cancelled. So I am left with minus x minus 5y is equal to 0. And if I send this thing on this side, I get 5y is equal to minus x. This is the equation of a straight line passing through origin, which is represented as this. We have negative x, so sorry, this region right here, and we have positive y. So upper side region. So we get like this. This is this equation of straight line. So basically, this is the locus of the point. So yeah, that's it for this video. Thank you for watching. If you enjoyed this, please do like and share. And if you do not subscribe or like, please consider commenting. Okay, thank you.